Hello friends, I am Pratima. I welcome you all to my video. I thank all the subscribers for supporting me to develop this channel. This is Modular Arithmetic Part 2. This is we will learn about the properties of the congruences and least residue of modulo n. If you have not watched the introductory part, I'll request you to watch it before watching this second part. Now, here we learn how to find least residue of modulo n by using congruences. And why this is useful? This is useful to find the residue of big numbers with big powers when divided by some numbers. So let us begin. Let us recall about modular congruences. Let us recall about modular congruences. It says if a and b are integers and n is a positive integer, then a is congruent to b modulo n if and only if n divides a minus b. So this is the symbol a congruent b modulo n if and only if n divides a minus b. Now let us see what are the properties we can use for congruences to find the residue. First is if a, b, c, d denote integers, m is positive integer, then if a is congruent to b modulo m, then b is also congruent to a modulo m. Second property is if a is congruent to b modulo m and b is congruent to c modulo m, then a is congruent to c modulo m. If a is congruent to b modulo m and c is any integer, then a plus c is congruent to b plus c modulo m. In the same way, if a is congruent to b modulo m, then for any integer, we can write a minus c is congruent to b minus c modulo m. If a is congruent to b modulo m, then a product of ac is congruent to product of bc modulo m. If a is congruent to b modulo m, then ac is congruent to bc modulo mc if c is greater than 0. If a is congruent to b modulo m and c is congruent to d modulo m, then a plus c is congruent to b plus d modulo m. If a is congruent to b modulo m and c is congruent to d modulo m, then a minus c is congruent to b minus d modulo m. If a is congruent to b modulo m, c is congruent to d modulo m, then product of ac is congruent to b times of d modulo m. If a is congruent to b modulo m, c is congruent to d modulo m, then product of ac is congruent to b times of d modulo m. This is the most useful property of congruences, power rule for congruences. If a is congruent to b modulo n and m is a positive integer, then a raised to the power m is congruent to b raised to the power m modulo n. So we'll learn how we will use these properties in solving problems. And some other properties are Fermat-Little theorem, Euler's theorem, and Chinese remainder theorem. In this session, we are not going or covering these theorems. Only on the basic properties we will solve some problems. So applications of these properties to find the least residue of a modular n. The least residue of a modular n is the remainder r that we obtain when we divide a by n. The integer r is one of the numbers 0, 1 up to n minus 1, and it satisfies a is congruent to r modulo n. So here one we should keep in mind that when we divide a with n is always positive. This remainder should be also positive. It is starting from 0 to n minus 1. That means the remainder should be from 0 to n. Then n. Now the procedure how to find the least residue. So I have taken 3 questions, and through the example we can understand how to find or what is the least residue. First is find the least residue of 32 modulo 7. So we know that when 32 is divided by 7, it is your 7 4 times 4 is the quotient and 5 is the remainder. So I'll write 32 is congruent to 5 modulo 7. Or the answer is, what is the least residue? 5 is the residue. Least residue. First one. Now coming to second one. Find the least residue of negative 33 modulo 7. So when it is a negative number, we have to be careful. So when we divide negative 33 division 7, so certainly this quotient is also negative. So it will be negative 33 over 7. It will be negative 4 point something. So it will be in between minus 5 to minus 4. So I cannot take this negative 4, I'll take negative 5. So I'll write this is equal to your 7 into minus 5, that will be minus 35 plus 2. So 2 is the residue here. So when I'll write negative 33 is congruent to, I'll write 2 modulo 7. So the least residue for B is your 2. Now coming to C1, C, find the least residue of 5 modulo 7. 5 when divided by 7. So when 5 divided by 7, it will be, what you will write, 7, 0 times is 7. Sorry, 7 multiplies 0 is 7. This should be plus 5. So the residue is your 5. Your 5 is the residue. So next some example for modulo 3. First is find the least residue of 9 modulo 3. First one. So we know that when 9 is divided by 3, we get 3 as quotient and remainder as 0. So it is simple. So your least residue is 0. or if you want to write in the modular form, it will be 9 is congruent to 0 modulo 3. Now part 2, it is -2, so it is little bit confusing. So take care, because this remainder will not be in negative. Remainder should be, or residue should be always positive, is positive. So we have to make the residue as positive. So what I'll do, I'll write this is equal to -2 is equal to 3 into -1 plus 1. So this is my remainder. Let me explain again. -2, if I'll divide it by 3, I'll write -1, then it will be -3, and I'll subtract, it will be 1 is the remainder. So here the residue will be 1. Now part C, least residue of -10 modulo 3. -10 modulo 3. -10 is divided by -3. So again what I'll write, -10. So you have to take a multiple of negative. So this will be -4. It will be higher than that. It will be -2. If we subtract, 2 is the residue. 2 is the remainder, or 2 is the residue. So this can be written as -10 is equal to 3 into -4 plus 2. After, if you have confusion, you can check again. Take this one and subtract this residue, so that this will be divisible by 3. Because a minus b should be divisible by n. You can check once after getting the answer. So this residue is 2 here. Next, least residue of 17 modulo 10. I've taken some example of modulo 10 because this is very important to find your last digit of a number when raised to certain power. It is asked in many competitive examinations. So A is 17 divided by 10. So it is easy. Question is 1 and remainder is 7. So this is your residue. Least residue is 7. So when it is least residue one, it should be the smallest one. Least residue of -1. -1 modulo 10. Then this will be, you have to take a number in a multiple should be negative. So I'll write this will be -1 is equal to 10 multiplies -1 plus 9. It can be. So 9 is the remainder here. Or you can think of -1 divided by 10, -1, -10, subtract it, it will be 9. So 9 is the remainder here, and so it will be the residue. Now third one, I hope you can try for third one, -38 modulo 10. Same thing, 10, 4 times -40. 10 into -4 is equal to -40. So -38 is equal to -40 plus 2. So 2 is the remainder. So 2 is remainder. And quotient is your -4. So LR is 2. Let us take another example and find the least residue of 171 plus 169 modulo 17. So we can keep an eye on this property. If A is congruent to B modulo M, C is congruent to D modulo M, then A plus C is congruent to B plus D modulo M. So first I'll get 171 is congruent to what modulo 17. That means 171 division 17, what is the residue or what is the least residue? It will be 1 because 10 is the quotient and 1 is remainder. So this will be 1 modulo 17. Similarly, 169 is congruent to 169 division by 17. I'll write this is 170 minus 1 division 17. So certainly negative 1 is the residue. So this will be negative 1 modulo 70. Now the question is, we can write 169 division 17, 79 times your 153, here 9 minus 3 is 6 and 1. I can write, but I want to write in the least thing, smallest one, so that this calculation will be easier. Then it will be negative 117 minus 6, negative 17. I can also write 16 modulo 17, but I'm preferring this one. Now 171 plus 169 plus 17 is same as 1 modulo 17 minus 1 modulo 17. So minus 1 plus 1 modulo 17, or this will be 0 modulo 17. So the remainder is 0. The residue is 0. Least residue is 0. Now coming to this one, I could have taken this also. It will be same 171 plus 169 modulo 17 is equal to 1 plus 16 modulo 17, that is equal to 17 modulo 17. Certainly the remainder is here 0. So 17 is congruent to 0 modulo 17. So least residue is 0. So certainly this method is simple to calculate. Another example, 601 minus 6001. Find the least residue of 601 minus 6001 modulo 6. So 601 is congruent to 1 modulo 6, because when I'll divide with 6, certainly the remainder will be 1. And 6001 is also congruent to 1 modulo 6. When you divide with 6, the remainder is again 1. So 601 minus 6001 modulo 6 is same as your 1 minus 1 modulo 6. That will be 0 modulo 6. So 0 is least residue. You can verify it. If we will simplify this, it will be negative 5400. Certainly this is divisible by 6. So remainder is 0. Next is on the property A is congruent to B modulo M, C is congruent to D modulo M, then A product of A C is congruent to product of B D modulo M. So on this property, we'll solve this example. Find the least residue of 17 multiplies 14 modulo M. So if we take 17 is congruent to minus 2 modulo 19. And 14 is congruent to negative 5 modulo 19. Now, when I'll write 17 multiplication 14 modulo 19 is the same as negative 2 multiplies negative 5 modulo 19. So this is equal to 10 modulo 19. 10 modulo 19 is 10 is the remainder, or least residue is 10. Find the least residue of negative 61 and negative 46 modulo 8. Negative 61 is congruent to 3 modulo 8. So the 8 8s are 64 and 61, so this will be 3. Similarly, negative 46 is congruent to 8 6 are 48, so this is 2 modulus 8. So when I'll write negative 61 multiplies negative 46 modulo 8 is nothing but your 3 into 2 modulo 8. So that will be 6 modulo 8. Least residue is 6. Next is power rule for congruences. This is the most important or useful rule for which helps us to simplify many problems asked in the competitive examination and maths Olympiad. If A is congruent to B modulo n and m is positive integer, then A raised to the power m is congruent to B raised to the power n modulo n. So on this basis, we'll first solve a simple question, find the least residue of 19 raised to the power 5 modulo 9. So 19 when divided by 9, we get 2 quotient and 1 is remainder. So 19 is congruent to 1 modulo 9. So 19 raised to the power 5 will be congruent to 1 raised to the power 5 modulo 9. As this said, A is congruent to B modulo n, then a raised to the power m is congruent to b raised to the power m modulo n. So here, this is 19, sorry. A is 19 and b is 1 and this m is your 5. So 1 raised to the 5 is 1 again. So 1 modulo 9, that means 1 is least residue. So you must be excited to solve more problems. 25 raised to the 25 is modulo 6. So let us go for 25. 25 division 6 is again 4 is quotient and 1 is remainder. So 25 is congruent to 1 modulo 6. So 25 raised to the power 25 is congruent to 1 raised to the power 25 modulo 6. 1 raised to the power 25 is again 1. 1 more 6. So 1 is least residue. Twenty-five raised to the 25 modulo 13. We have to find the least residue. Now coming to 25 is congruent to, I cannot write the 25 divided by 13 is equal to 1, 13, 12. Because if I take 12 as the residue, that means 12 to the power 25 I have to find out. So what I'll do, I'll write 13, 25, I'll get 2, 26 and the remainder is negative 1. Because negative, when I'll take 25 raised to the power 25, then either it will be, if I'll take this one, it will be 12 to the power 25. If I'll take this one, it will be negative 1 to the power 25. So this will be more simpler. So I'll take this one. So 25 is equal to negative 1 modulo 30. So 25 raised to the power 25 is congruent to negative 1 raised to the power 25 to 13. And you know that negative 1, if it is odd power, then it is negative 1. And if this is even, then you will get positive 1. So this will be negative 1 mod 30. Then is the least residue is negative 1? No, because residue will be written in always positive. So I'll write 13 minus 1, that will be 12 is the least residue. Another example, find the least residue of negative 9 raised to the power 4 modulo 6. So a negative 9 raised to the power 4, this is same meaning as 9 raised to the 4. I'll get modulo 6. So 9, now let us take first 9. 9 is congruent to 3 modulo 6. So 9 divided by 6, the remainder is 3. So when write 9 raised to the power 4 is congruent to, it should be 3 raised to the 4 modulo 6. 3 raised to the 4 is 81. Instead of 81, I am writing 9 to the power 2 modulo 6. Now coming to 9. 9 is congruent to 3 modulo 6. We have already written. So 9 raised to the power 2 is congruent to 3 raised to the power 2 modulo 6. So 3 raised to the power 2 is 9. So 9 modulo 6 is again 3 modulo 6. So least residue is 3. Find the least residue of 16 raised to the 9 modulo 3. This is for your practice. Before seeing the answer, you can solve yourself if you are really interested to learn. And if you will learn yourself, solve yourself, you can solve yourself, then my product will be a successful one. So 16 is congruent to 3 modulo 13. So 16 raised to the power 9 is congruent to 3 raised to the power 9 modulo 13. Now let us come to 3 to the power 9. 3 to the power 9 can be written as 3 to the power 3 multiplies 3 to the power 3 multiplies 3 to the power 3. 3 to the power 3 means your 27. So that is equivalent to 1 modulo 13 because 3 raised to the power 13, 3 is 27. 27 is 1 modulo 13. So 3 to the power 9 modulo 13 can be written as 1 multiplies 1 multiplies 1 modulo 13. This is equal to 1 modulo 13. Its residue is 1. Thanks for watching. Like and comment. Please subscribe. Next video will be solving problems related to unit plus digit of any power, applying these congruences and least residue, which is asked in many competitive examinations. Thank you.